Large language models like GPT, despite being widely read, still have persistent weaknesses in certain areas, such as fabricating facts, making inaccurate calculations, and relying on outdated data. To address these issues, we can empower AI with external tools or data. Frameworks that implement this idea include RAG retrieval, augmented generation, PAL program, aided language models, and ReAct reasoning and acting. These terms might sound obscure and confusing, but don't worry, we'll explain them one by one. The knowledge possessed by large language models is influenced by their training data. If the training data lacks sufficient coverage in a particular field, the AI learns little about it and cannot answer related questions well. Therefore, in niche or specialized domains, the AI's performance may be unsatisfactory. Moreover, internal company data, personal private documents, and the like cannot serve as training data for publicly available large language models. We cannot expect ChatGPT to answer related questions for us. So what can we do? All-in solution is to provide external documents, allowing the model to access an external knowledge base to obtain real-time and accurate data, generating more reliable and precise answers. This architecture is called retrieval, augmented generation, or RAG for short. Specifically, external knowledge documents are first split into paragraphs because large language models have a limited capacity for text input at one time. Each paragraph is then converted into a series of vectors, which can be thought of as fixed-length sequences of numbers and stored in a vector database. When a question is asked, the query is also transformed into a vector, and the vector database is searched for paragraph vectors closest to the user's query vector. Once found, the paragraph information is combined with the original user query and passed together to the AI. This way, the AI can use the external document paragraphs as context to provide more rigorous answers based on the information within. As a result, you can ask questions about any content in the external documents, even if the AI model was never trained on that content. RAG is beneficial for building corporate or personal knowledge bases. Some ChatGPT plugins are based on the RAG architecture, and OpenAI has also introduced a feature that allows uploading PDFs and asking questions about them. If you know how to use the GPT API, you can also implement your own retrieval, augmented generation with code. If you're interested, you can watch our follow-up course on large language model application development. Another issue with large language models is that we cannot use them as calculators. When we ask them to perform a mathematical calculation, they are not actually doing the computation. They are simply guessing the next most likely token to generate a response. If we want the AI to act as an online store customer service agent, it might eloquently introduce products, but also give customers incorrect order totals, which is dangerous. But what if we don't ask it to do the calculation and instead provide it with the computed result? Program-aided language models, or PAL for short, can help us address such problems. PAL was first proposed in a paper in 2022. The core idea of PAL is that instead of having the AI directly generate calculation results, we leverage other tools better suited for computation, such as a Python interpreter. Our instruction to the AI then becomes, when calculation steps are involved, generate the code needed to obtain the result. Specifically, to ensure the AI follows our requirements, we can use chain of thought prompting. If you're not familiar with chain of thought, you can watch the previous video. First, in the prompt, we use few short examples to demonstrate step-by-step thinking to the model, showing how to write variable assignments, mathematical operations, and other code needed to solve the problem, so the model can mimic the approach. After the user asks a question, we combine the user's question with our existing prompt template and give it to the AI to generate the code. Next, we take the AI's response and feed it to a Python interpreter, which executes the code and returns the calculation result. This result can then be passed back to the AI, allowing it to properly respond to the user's question with a computed answer. In essence, we are leveraging the large language model's ears to receive questions, brain to think, mouth to speak, and the code interpreter's hands to perform calculations. ChatGPT's advanced data analysis feature can be seen as an example of PAL. With its built-in Python interpreter, ChatGPT can use programming logic and code execution to answer questions more accurately. If you know how to write code, combining the GPT API to implement program assistance is also relatively straightforward. Another limitation of large language models is that the knowledge they possess is inherently constrained by the date of their training data. For example, its training data certainly does not include this year's news, so the model cannot know about events that occurred after its training was completed. This is known as the knowledge cutoff. When we ask the model about recent facts, it may either provide outdated information or fabricate answers entirely. However, retraining the model is quite costly and does not completely solve the problem of outdated data. It would be great if the AI could search the internet for information it doesn't know and then tell us the answers. But how would it know which websites to browse or what keywords to focus on to find relevant information? A paper titled ReAct Synergizing Reasoning and Acting in Language Models, published in 2022, proposed the ReAct framework. This is not ReAct, the popular front-end framework, but rather ReAct short for reasoning and acting. The core of ReAct is enabling the model to engage in dynamic reasoning and take actions to interact with the external environment. It can also be combined with chain-of-thought prompting. We use few-shot examples to show the model a framework that integrates reasoning and acting, meaning breaking down steps for a given problem, where each step involves reasoning, action, and observation. Reasoning involves thinking about the problem or the observation from the previous step. Action is the interaction with the external environment based on reasoning, such as using a search engine to look up keywords. Observation is reviewing the results obtained from the action. For example, if you ask a large language model with a knowledge cutoff of January 2022, which team won the Champions League in 2022, it would not be able to answer. But if we give the AI access to a search engine as an interactive tool and apply the ReAct framework, the process of obtaining the answer might look like this. First, regarding the question, it would reason that to answer this, it needs to look up match results. Since this AI can use Bing, its subsequent action would be to search for the keywords 2022 UEFA Champions League champion. Next, it observes the results of the action, obtaining a series of web pages containing Champions League information. Based on the results from the previous step, it begins a new round of reasoning. A news website link mentions the final, so it likely contains the needed information. The corresponding action for this step is to click on that link. After entering the web page, it observes a passage mentioning the winning team, along with details about the final opponent and score. It then continues reasoning based on this information. The next step should be to cite the information and provide the answer to the user. Therefore, the final action is to summarize the found information and present the final answer to the user. Through ReAct, we can see the model's step-by-step problem-solving trajectory toward the answer, which is quite similar to how humans approach tasks. By using step-by-step reasoning via chain of thought, the model can not only obtain more accurate answers, but also allow us to verify the process through these trajectories. Furthermore, the observation and action steps increase interaction with the external environment, helping the model overcome certain inherent limitations. For example, inputting keywords into a search engine or viewing information on web pages can mitigate the impact of knowledge cutoff. Features like ChatGPT's web browsing function enhance its ability to interact with Bing search, enabling it to answer questions about real-time information. This helps users verify the reliability and authenticity of information sources. Additionally, the action in the ReAct framework is not limited to searching and browsing the web. It refers to any action the AI model supports. For instance, if the model can interact with a code interpreter, running code can be an action option. If it can access external documents, searching for keywords within those documents can be an action option. If it can call an application's API, interacting with that application can also be an action option to leverage different external data and tools for the model programmatically. Frameworks like LangChain can be used to simplify the process of building large language model applications. If you are interested, you can watch our introductory course on large language model development. I hope this series of educational videos has helped you build a better understanding of generative AI, large language models, and the technical foundations behind popular applications like ChatGPT. While others may feel overwhelmed by the constant emergence of dazzling new applications, you can remain steady and adaptable. If you found this helpful, don't forget to give it a like before you go. See you next time.